Hello everybody. Today's lesson is going to cover operations with functions, and the specific operation that we are going to cover is going to be multiplication. The next one we'll talk about is division, and this one's going to be another really simple lesson because it's basically stuff that you've done before. We're just kind of doing it in a different context. We're just applying it to functions rather than just polynomials, for instance. So let's go ahead and get started here. Okay, so I think maybe the most tricky thing with this is just the notation of these function problems. And right here, we're given a bunch of information, okay, and that's important. You need that information in order to do any of the arithmetic that is being asked for this specific problem. We have an f of x function right here, and we have a g of x function here. And it just says find the h of x, which is basically what is the product of those functions. So this problem right here is telling us, and I know it's sometimes math problems can look like a foreign language, but what you have here is, you have that binary symbol right there, which represents multiplication, as you probably already know. And it's just stating that we are going to multiply the f function times the g function. And this x out here doesn't really mean anything other than you're going to find the product of f and g of x. There's nothing really to it. What we're going to do is we're going to multiply the f function. Now the f function is x squared minus 1, and the g function is x plus 5. So you're going to multiply it like that. And if that looks familiar to you, it should, because we've done that. We've done quite a bit with that, especially when we were covering our polynomial unit. And the one way that I kind of preferred was kind of using the array method, or the area model, I guess, where you just kind of set up I think some of you call it the box method. All right, so if you set your terms up around the perimeter of that box, you guys can figure out what the products are. So we've got x squared times x, which is x cubed. We've got x times negative 1, which basically just means negative 1x or negative x. 5 times x squared is just putting those together. And then 5 times negative 1 is negative 5. Okay, so we just did all the arithmetic there. Now we just have to put together if we have like terms, and we actually don't have any like terms on this one. So we are all set. So the h of x for this one, the h of x is going to equal x cubed plus 5x squared minus x minus 5. And that's it. So make sure, I think with these kind of problems, make sure you're putting everything in descending order. Make sure everything, if you have like terms that can be collected, put those together. If things cancel out, you don't need to show them anymore, just get rid of them. So that is it for that one. That was your first example. We're only doing 2 examples here. These are pretty simple. All right, so the next one is, it's got some kind of extra information here, but we've got the f function right here, 3x minus 1. We have a g function. The g function is 2x squared minus 3. And you have an h function right here. Now this one is written a little bit differently than the other one, and you just kind of have to get used to that. Sometimes they're going to be kind of just presented differently. Don't be thrown off by it. But this has got the binary symbol there, which represents multiplication again. And this is just going to be a matter of multiplying one expression, or one polynomial, I guess, or these are binomials. We're going to multiply one binomial times another binomial. And that's really all there is to it. I'm going to set up a 2x2 area model here, just like we did before. Remember, if you're multiplying 3 terms by 2, then you can do a 3x2 array. It doesn't really matter. I mean, if you're doing 3 terms by 3 terms, it could be 3x3. So I'm going to put 3x minus 1 up there. And then the g of x function, we've got 2x squared minus 3. All right, now I'm just going to go through the whole process here of multiplying it. So that's got a product of 6x cubed minus 2x squared minus 9x, and then a negative times a negative is a positive. Just like what happened on the last problem, there aren't any like terms. There's no other cubes, there's no other x squares, there's no other just x's, and there's no other constants. And so it's just a matter of just putting it all in descending order. So I'm just going to write down the answer is 6x cubed minus 2x squared minus 9x plus 3. So that's all there is to it. I mean, sometimes you might notice that it will, I mean, I think, I don't think any of the practice problems will show that, but it might say like, you know, what's the f function of 2 times the g function of 3? Well, if that is the case, then what you're going to have to do is you're going to have to put that 2 in for x into the f function, and you're going to have to put 3 in for x into the g function, and then work them out that way. But like I said, I don't think any of the problems are going to come out that way, but just kind of be on the lookout for that. You'll see that from time to time. Also, like kind of going back to the first one, you might sometimes see it where it's like f of g, or f times g, I should say. And then there might be like a coefficient or a factor right in front of it. Like let's say there's a 7 right there. And what that's basically just telling you is find the product of the f and g function, you know, the f function times the g function. And then when you're through with that, multiply by 7. So notice how that 7 is outside of the parentheses. So that's like the last thing you actually have to apply to it. But like I said, I don't think you're actually going to encounter any of those kind of problems today. But they are, you know, you're probably wondering, when is this going to get tricky? It is, like everything in algebra. Things are going to get a little bit more difficult. But for right now, again, this is just another easy lesson. Hopefully this is not stressing you out too much. And that is it. So everyone stay safe, stay healthy and all that. And have a great day, everybody.